Okay, this is a summer calculus packet that will be great review, topics that you're definitely going to use in calculus that you're going to want to know. And as you know, if you spend all summer not practicing this stuff, you will forget it. So this is really good practice to do. I would say sometime this summer would be really the best. But maybe do it now at the end of the school year and sometime in the summer, whenever you're watching this or whenever you're trying that. But the first topic is on fractional and negative exponents. So the first problem here, I'm just going to do a couple problems from each section, one or two depending. And hopefully that helps enough to get you going. But the first problem wants to simplify using positive exponents. So what we can do is put this over and make it x cubed, because we know that if you change the sign on an exponent, then you flip it from the numerator to denominator or vice versa. So this thing really quickly just simplifies into this rational expression right here. All right, so let me try a harder one then. This is number 7 on there. It wants us to multiply -4 times this. Now I'm going to get rid of this negative sign by flipping this fraction. So if I flip it, the 2x plus 1 goes to the numerator, and the 2x minus 1 goes to the denominator. Now I still need to multiply that by what's here. So I still have 2 times 2x plus 1 minus 2 times 2x minus 1 all over 2x plus 1 squared. Now obviously, you know, one of these factors can cancel with one of these factors because they're the same, 2x plus 1. So I'm going to cross reduce as much as I can. Let's see. I'm going to have to start multiplying things out now because I can't cancel, like this factor won't cancel with that one because they're not being multiplied. This one's not being multiplied by everything. And keep in mind, like when you have like, you know, 2 times 3 over 2, for example, you can cancel those, right? That's really 6 over 2, which is 3, or if you reduce it this way, it's 3. But if you have like 2 plus 3 over 2, you can't cancel these because 5 over 2 is not equal to 3. So when you're adding like this, which I am, I've got a minus sign, I can't just cancel those factors like that. So to multiply this out, I'm going to have -4 times 2, which is -8, times this quantity 2x plus 1, and then I'll have -2 times this quantity 2x minus 1, all over, I still have this and this, so it'd be 2x minus 1 times 2x plus 1. All right, now I'm going to distribute these. So that'd be -16 plus x plus -8, and then it'd be -4x plus 2 if I distribute these. All over this denominator distributed would be 4x squared. The middle terms are going to cancel, because I have plus and negative, the same thing, and then it's -1. Okay, so let me simplify by adding -8 plus 2, which makes -6, and also -4x, -16x make -20x. All right, so now I have this. Let me try to simplify a little bit further if I can. I'm going to factor out something from here, so why don't I do a -2? If I pull out a -2, I end up with 10x plus 3. all over 4x squared minus 1. And unfortunately, I don't think I can simplify that anymore, so it looks like that's my answer. All right, next we're going to find the domain of functions. The domain, what you need to look out for, the two main things you need to look out for are places where you have zeros in the bottom and places where you have undefined values under radicals. I guess I should say under even roots. So in this case, I don't have any roots. I don't have a square root or third root or fourth root or anything. So all I have is this fraction, which I can't have a 0 in the bottom. So what I'm going to do is find out where that happens at by setting this equal to 0. Subtract 1 from both sides and divide by 4, and you find out that at -0.25 or -1/4, if I stick that in, I get an undefined value because I'm dividing by 0, which doesn't make any sense. So that means that is the one value I can't have. So when I go to give my domain, I'm going to use interval notation. I'm going to say -infinity all the way up to that -1/4 because I can't include that. And then as well as -1/4 all the way to positive infinity. So there's my domain right there in interval notation, which you need to get used to writing because you will use that next year. And if you've forgotten how it works like this. Here's the number line. Here's 0. -1/4 is right here. We're putting an open circle there, and we're picking to graph all the points to the left of that, which is this part, -infinity all the way to -1/4, and all the parts to the right of that. But we're not including that one value in the middle right there, which is -1/4. So to try one more then, this time we have two things to look out for. We can't have zeros in the bottom, so if we solve that set that equal to 0, subtract, and divide, we get x equals negative 9/2. So we can't have x be equal to negative 9/2. That's an issue. But we also have to make sure that 2x minus 9, what's underneath this radical, we have to make sure that is greater than or equal to 0. It can be 0, that's fine. We can have a 0 up there, but we can't have a negative underneath a radical. So that's the other thing I'm going to have to solve and look out for. I'm going to add 9 to both sides and then divide by 2. So x has to be greater than or equal to 9/2. So these are the two things that I have to consider when I go to write my inequality. So when I go to write my interval, rather, not inequality, interval, negative infinity, well, actually, I want all the values that are greater than 9/2. I can't have negative 9/2. Well, just this satisfies it then. If you look at a number line, it sometimes helps to visualize this. Negative or 9/2 is, here's 0, that'd be 4.5. So what it's saying is we need that value and all the values that are bigger than that. So we're going to the right. And that's fine because negative 9/2, we can't have that value, but that's down here at negative 4.5. So we don't, as long as we just say this, we don't have to worry about that. So that's our answer. Now we can put that in interval notation, which is what we want to do. That in interval notation would be 9/2 all the way up to positive infinity, but we can include 9/2. We're going to put a bracket here instead of a parenthesis because we are including that point right there. Okay, logarithms are something you're going to want to review. Well, this one wants us to solve this for x, and there's different ways to do this. We could write a log equation and do log base 6 of 36 equals x plus 1, because this is transferring from exponential form into log form, if you recall. And then we could subtract 1 and solve in our calculator. But if we're doing this without a calculator, what we can do is use the one-to-one property. The one-to-one property says if you get the same base on both sides, you can compare the exponents. So 36 is really 6 squared. So we have the same base. Now we can just say, okay, well, these have to be equal to one another. So x plus 1 has to equal to 2. Obviously, x equals 1 then. And that's our answer. We can try to do a little bit more challenging one here. We have to, first of all, put this into one logarithm, so we have to simplify this. So I'm going to write this as log base 10. This is really x to the 1/2 power, right? And another property we learned is that we can bring this 2 up. So if we bring this 2 up, it becomes a power right here, which I can multiply. All right, so it's like this gets raised to that power, which I can multiply and turn that into then log base 10 of x to the first. Now plus, I'm going to do the same thing over here. I'm going to bring this up. So it'd be plus log base 10 x to the 4/3 times 3. These 3's would cancel, and I'd get log base 10 of x to the 4th. And now I can simplify because I learned the sum of two logs is really the log of a product. That's a formula I put on my formula sheet. I guess I should call it an identity. So I can multiply these, right? Because the log of a product is really the sum of two different logs. Going this way, you can go the other way by saying the sum of two different logs is the log of the product. So that equals log base 10 of x to the 5th. When you multiply exponents, you add them. Now, I can try to simplify a little bit more. Let me call this equal to y, and I can say, well, put it in exponential form, 10 to the y equals x to the 5th. And that gets us absolutely nowhere. Sorry about that. This is your answer. I should have known. I mean, we don't know what this equals, but we also don't know what the base is, so there's no way for us to know what it equals. We have one equation with two variables right here. So that was a really bad idea to stop here. And this just wanted us to simplify anyway. So there, we've simplified it. Okay, quick reminder of absolute values to solve these. What you have to do is take what's underneath, or what's inside the absolute value, and set it greater than 12, and then take what's inside the absolute value and switch the sense of the inequality and the sign on one side. So I'll do it to the right side here. And you get these two equalities or inequalities, and we can then add 3 to both sides. You get x is greater than 15. Add 3 over here, you get x is less than negative 9. And so it always helps me to do a quick number line and say I want x is less than negative 9 and x is greater than 15. So what that looks like is an open circle here to the left, open circle here to the right. So in interval notation then, which is how we want to write things, it's negative infinity all the way to negative 9, not including negative 9, as well as 15 all the way to positive infinity, not including 15. So there's my answer in interval notation. Inequality notation, we'd have to say x is less than negative 9 or x is greater than 15. But this is typically probably what you're going to use more of next year probably. Let's just try one more real quick. Take what's inside, x minus 6, keep everything the same, then take what's inside and switch the inequality and switch the sign on one side, and now solve. Add 6 to both sides, you get x is greater than negative 2. Add 6 to both sides, you get x is less than 14. And once again, I like to graph. Negative 2 is here, 14 is here. Now, these are going at each other, so I want all the values that are greater than negative 2, and I want all the values that are less than 14. So what we're talking about is the part in the middle here, and I can write that as a compound inequality. Negative 2 is less than x is less than 14, or in interval notation, negative 2 to 14, not including either. All right, next, don't forget how to fit a line to 2 points. This is from way back in algebra, probably. Running a line through these 2 points, you could find the slope first by doing y2 minus y1 over x2 minus x1, which case you get negative 8 over double negatives go positive. There's the slope, negative 8/3. Now, I'm going to do, actually, I'll do point slope form. Y minus y1 equals m times x minus x1, because then I can just plug in the 1 point. The slope is negative 8/3. One of these points, I'll use the first one, x minus negative 1 and y minus 3. There's my equation. Double negatives can go positive, so I can simplify this and do a plus. And I could even put it in slope-intercept form if I distributed and moved the 3 over. But they just wanted an equation of a line, so I'll leave it just like that. Okay, don't forget how to solve quadratic inequalities. So if you're solving this, I'm going to factor this first into x plus 8 and x minus 2. Just guess and check until you get what you're looking for here. Now that's greater than or equal to 0. So if you're going to solve this by hand without a calculator, what we did is earlier in the year we made a sign chart. And on the sign chart we put the key points, which were the places that the function was 0 and the places where it was undefined. In this case we have negative 8 is a 0 and also 2. And what we did is we test the sign on each of those portions. So I'm going to plug in a number less than negative 8, like negative 9. When you plug in a negative 9, you get a negative here and a negative there. Double negatives go positive, and that satisfies the inequality because that's greater than 0. So that's going to be positive there. Now if I plug in a number between negative 8 and 2, what I get is, like, for example, 0. 0 gives me a positive here and a negative there, so that would give me a negative in that region. And if I plug in a number bigger than 2, like 3, 3 gives me a positive and a positive, which stays positive. So what I'm looking for are the places where this is positive. So my answers then are all the way up to here. And I can't include negative 8 because that's actually 0. And I can't include 2 because that's a 0 as well. So there's my answer, negative infinity all the way up to negative 8, not including negative 8, as well as 2 all the way up to positive infinity, not including 2. So there's my solution right there. You can write that as an inequality, but an interval is probably better.